So when we're talking fractions in this next lesson, you're going to multiply by the denominator?
Yeah.
Denominator. C2H6. C2H6. That is ethane. That's an actual organic molecule. That is the molecular formula. What would be the smallest whole number ratio for that? Brandon?
1 to 3.
1 to 3. Smallest whole number ratio. So this is an empirical formula, the smallest whole number ratio. And then this is the actual ratio. So we have molecular formulas and we have empirical formulas. So this note is about how we determine an empirical formula. How do we go from an empirical formula to a molecular formula, or vice versa? Okay? So combustion analysis, we talked about that yesterday. It's an analytical technique used to help identify unknown organic compounds. An organic compound contains carbon, hydrogen, and sometimes oxygen, nitrogen, or sulfur. The sample is burned with enough oxygen that complete combustion occurs. Carbon dioxide and water are removed and their mass is determined. From this information, the percent hydrogen in the original sample can be determined. A mass spectrometer can also be used to determine the molecular mass of the original sample. These instruments can be used to determine the empirical and molecular formula of a compound. So, definition, it's bolded, and then there's italics used. An empirical formula is the simplest whole number ratio of atoms or ions in a compound. It is an empirical formula because we get this information from an experiment. Experiment means empirical evidence. The empirical formula is often different from the molecular formula. The molecular formula gives the exact whole number ratios of atoms in a molecule. So formula then for N2O4. NO2. We divide. So we have the lowest whole number ratio. So we divide N2O4 by 2. Oh, we just did C2H6. So it's CH3. How about H2O? What's its lowest whole number ratio? H2O. Sometimes your empirical formula is the same as your molecular formula. So, there are steps to figure out the empirical formula if you're given percent composition. So percents are parts per hundred, so it's really simple for our calculations to assume a 100-gram sample. So I want you to write, the very first thing you're going to write when you start solving a question is assume a 100-gram sample. Number 2, calculate the moles of the element. So you're going to calculate small n. Then you divide the moles by the smallest number of moles, and that gives you the ratio of atoms to other atoms in the compound. Okay? So these subscripts. Write the empirical formula using the element symbols and the ratios as subscripts. So we're going to do an example. What is the empirical formula for a compound with a percent composition 79.9% carbon, 20.1% hydrogen. First thing we do, assume a 100-gram sample. Right there, 1 mark. And the reason being, bless you, is in chemistry, we don't just switch units on numbers. We have to give an explanation why we're changing the units. So if we assume a 100-gram sample, that means we have 79.9 grams of carbon. And we have 20.1 grams of hydrogen. It says calculate the moles of each element. You can use dimensional analysis, but a formula is really easy here because we can just go down the page. What is the symbol for moles? Little n. What is the formula once we know mass? M over big M. So, take the molar mass of carbon and put it underneath the mass of carbon. Take the mass of hydrogen and put it over the molar mass of hydrogen and do the math.
For carbon, 6.65.
6.65. Give me at least one more significant digit. 2. We've got 4 significant digits right now because there's minimum 3 in our final answer, but this is not our final answer. And then, how many hydrogens?
19.90.
19.90. Ooh. All right. Which one of those is smaller? Take that small number and divide it into both of those moles, and we will get a ratio for each of these elements. So, you all right? Just gonna kind of die over there? Okay. You allergic to anything?
Nope.
That will help you through. Okay, what did we get then for the ratio for hydrogen? Yeah?
2.99.
2.99H. And can we round that off?
Yeah.
Yes. So that means for every 1 carbon in our compound, we need 3 hydrogens. So, the empirical formula is CH3, because we don't have to write the 1. So what you do is you take 1 carbon and you add 3 hydrogens to it. Now what you do is you take the molar mass that the mass spectrometer produced for you, and you see how many times that molar mass fits into the molar mass of your sample. And that will give you a multiplier, which will be a whole number, to multiply by this to give you your actual chemical formula for your compound. So, for example 2, the compound with a percent composition of 79.9 and 20.1, the molar mass of the compound is 30 grams per mole. What's the molecular formula? So, I know what the molar mass of my empirical formula is. So I take my molar mass of my compound, divide it by the molar mass of my empirical formula, and that tells me how many times my empirical formula fits into my molecular formula. So if I take that number and multiply the subscripts in my empirical formula, I will have my molecular formula. So CH3 times 2, C2H6 is the molecular formula. Yep.
Where do we get the 30 grams?
It would have to be given to you. Yeah, it would have to be given to you in the question. You okay